Hi there, folks. It's Root Beer, and I thought I would continue looking at some compass and straight edge constructions. Let's get the straight edge tool back rather than the segment tool. In this video, I thought I'd show you not so much a practical thing like duplicating an angle or creating a square, but I thought I'd show you something I think is pretty nifty. It's a picture that encapsulates 4 of the basic power means. So the harmonic mean, the geometric mean, the arithmetic mean, and the quadratic mean. So what we're going to do is we're going to start with some lengths. Oh, I do need the segment tool, don't I? So we're going to start with some lengths, sort of an A and a B. And we're going to be able to construct a single figure. It's actually quite a nice looking figure, just inside a semicircle. But we'll be able to distinguish some lengths inside it that will represent the harmonic mean, which is a to the minus 1 plus b to the minus 1 all over 2, and then all of that to the minus 1. And so that's another way to say it is 2 over 1 over a plus 1 over b. We'll also have a length that is the geometric mean, which is the square root of a times b. We'll have another length, which is the arithmetic mean, which is the basic average of 2 numbers, a plus b over 2, or to make the connection with the harmonic mean, a to the 1 plus b to the 1 over 2, all to the power of 1. And then we'll also have another length which will represent the quadratic mean, which is a rarer one. The first 3 that I mentioned are what are called Pythagorean means, and they have fun relationships, but there are more means. For example, the quadratic mean will also make an appearance, and that is a squared plus b squared all over 2 to the 1/2. So you notice when I say a to the p plus b to the p all over 2 all to the 1 over p, that's sort of the pattern that connects the harmonic mean, the arithmetic mean, and the quadratic mean. And the geometric mean is just an interesting limiting case. Now, what you can do is you can just sort of you can attach one of these lengths to the other one. I'm not going to do that. I'm actually just going to pick another point and construct from there. The reason being, I want to then at the end have my picture, and then be able to vary these lengths and show you the picture varies and everything all works out. So I shouldn't have put those segments in because I need to name some points, and I don't want to name these segments. Not right now, anyway. So we're going to have to duplicate these lengths because I want them all on a line going through E. So what are we going to do? Well, how do we duplicate lengths? Parallelograms. Okay, so we got some parallelogram work with both of these. So I need a line through A parallel to BE, and I will also need a line through E parallel to BA. So start with whichever one I feel like. Let's get the line through A parallel to BE. So what do we need? We need a line through B perpendicular to BE. Fantastic. We get another point up here. Connect that up to A, and then there's another point with the intersection of these 2 circles. And that gives us a chord through A that is perpendicular to a line perpendicular to BE, and so is therefore parallel to BE. So we're going to hide our work, and then we're going to do the same thing, but to get a line through E parallel to AB. That'll create a parallelogram for us. And so that'll reproduce the length AB. Alright, so points here and points here. Need a perpendicular bisector. bisector in the original circle, intersection to E, other point, and connect them up. Okay, so now we have our two parallel lines. We have our parallelogram constructed. We just need to distinguish their intersection, and that will have the same length as AB. And then we'll do the same sort of thing with CD. So there we go. So we're going to keep this line around because I'm going to create my parallelogram with CD, and I mean, these sort of look like they're on a line, but we can move them however we want. We're going to be able to duplicate CD, and then we're going to bring that back down onto this line, and then everything is going to, our semicircle will be constructed off of this line. But you can see this is indeed, it's both parallel to AB, and this dot to E represents our length AB. Okay, so we got to duplicate CD. So let's get to it. So we need a line going through D, parallel to EC. We'll have done this construction 4 times at least by the end. I think it's only 4 times because we just need the parallelogram stuff to get our lengths on a line together. All right. So there we've got our line parallel to CE through D. Okay, so we're looking pretty good there. And now we don't want this intersection point. We still want a line through E parallel to CD, so let's get cracking on that. Connect it up to E, other point creates the end point for a chord. That chord is perpendicular to the line, perpendicular to CD, so it goes through E and is parallel to CD. A bit more cleanup is necessary, but we need this intersection point here, and that's it. The other lines can go. Alright, now we've duplicated CD with one of the endpoints at E. Use our circle tool here to now get the length CD on the line. Okay, we can zoom in a little bit and we can clear up a bit more. Now we'll move the whole picture down a little bit so it's a little more in frame. Okay, so now we've got our lengths all on the same line. And we can really check, yes, this is the same length. Okay, so as we vary A and B and C and D, these lengths will change, and really varying E just moves this, this line here. Okay. So, what do we need to do? Well, what we're going to do is we're going to use these 2 points here to be the endpoints of a semicircle. Okay, I'm gonna have to use a full circular arc just because it's GeoGebra. I don't think we have a semicircle tool. Oh, we do have a semicircle through 2 points, but I think I'd rather just stick with the 3 main tools that I use, which is the point, the straight edge, and the circle tool. We'll illustrate the line segments later that give us the harmonic mean, geometric mean, arithmetic mean, and quadratic mean. So what do we need? Well, we need to get a semicircle here. First, let's consider what is the distance between these 2 points. Well, it's the AB length, which I'm going to call little a, and the CD length, which I'm going to call little b. So in total, this is little a plus little b. What's the midpoint? Well, it's little a plus little b over 2. So that's going to be the radius. And little a plus little b over 2, why, that's the arithmetic mean. Okay. So we get the midpoint of those two constructed points, but it also gives us the center of a circle whose radius is the arithmetic mean. So really we could label any of these 4 radii our arithmetic mean. We're not going to do that right now. We're going to, just to keep it in line with the picture that I like, I'm going to label a very specific one, but we don't need that yet. Okay. So, what is it that we do next? Trying to remember. Oh, okay. So we have a choice of either geometric mean or quadratic mean. So I'm going to label this point. I don't like the label R. So we're going to rename this guy to F. And this one will be named G, even though apparently it's H1. Interesting. So we'll rename him as G, because I'd like to refer to these guys a little bit. So F to E is the same as A to B, E to G is the same as C to D. So what's left here between E and the center? Well, what do we need to add to little a in order to get little a plus little b over 2? We need to get b, the bigger length, minus a all over 2. So this is actually their difference divided by 2. So b minus a over 2 squared plus a plus b over 2 squared. So we have a right angle there. So we can get a hypotenuse. If you do the math, then it turns out that the hypotenuse squared is a squared plus b squared over 2. And so then we just want to square root that, and we get the quadratic mean. Okay, so the e to our point up here at the top of the circle is the quadratic mean. So we're not going to need that right now. I just thought I'd illustrate that length. What I do want is a line perpendicular to our diameter going through E. And that will give us the geometric mean of A and B. Because E is exactly where it splits between the little a and the little b lengths. So we distinguish this point up here. We're all set. I'll clean up that construction. Now E to that, not to the very top of the circle, but E to the point directly above it is the geometric mean of A and B. And you can use the fact that any point on the semicircle connected to the endpoints of a semicircle gets a right angle, and then we got some right angles. So there's some similar triangle work going on. In fact, there's a similar triangle work going on to get the harmonic mean. I'm just trying to remember how to get the harmonic mean now. I'm just going to shrink that and zoom in a little bit so I have a bit more space. Okay, so the quadratic mean, we go this way, and the arithmetic mean is the radius. So if I connect up these 2 points, I will get the arithmetic mean. So arithmetic mean as a hypotenuse and geometric mean as one of the legs. If I can create a smaller similar triangle with the geometric mean as the hypotenuse, the harmonic mean will be a corresponding leg. So I mentioned at the start that harmonic mean, geometric mean, arithmetic mean have nice relationships. One of them is that they are in geometric progression. Arithmetic mean divided by geometric mean is the same as geometric mean divided by harmonic mean. And that's something you can prove from their formulas as well. So what do we need to do? Well, we need to make a similar triangle with our geometric mean as the hypotenuse. Maybe it's a good time now to actually label the segments that I'm interested in. So we'll get the segment tool out, and we'll get red for the arithmetic mean. Oops. We'll rename this to AM for arithmetic mean. What color shall we use? We'll use purple for the geometric mean. And what's a good one for the quadratic mean? I'm thinking gold. So QM for quadratic mean. There we go. And now we just need the harmonic mean, which I'll probably do in light blue. So, as I say, we want similar triangles. So we need to construct a right angle triangle right angle triangle with GM as a hypotenuse. So we need to drop a perpendicular from E to this brand new green line that I've created. So how are we going to do that? I connect up E to that point, and we get this point right here. And bisector through these guys should pass through E and give us a right angle. And it does. So we get this point down here, and we'll clean up a little bit. Alright, and so get line segment, we'll make it cyan. And oops. Want to right click, not regular click on that. So we're going to rename this HM for the harmonic mean, although that's a little faint. Do I want to change color? Forest green? Forest green looks a little better. Okay. So just for the sake of completeness, for showing off, oops. Make him forest green. But I'm going to make these other ones black. Just so you can sort of see where the construction's coming from. And now we are going to hide this line here. And then F to E, we're going to make that hot pink, and we're going to label that little a, and we're going to get E to G, and that's not going to be hot pink anymore. We're going to make it lavender. Nah, it's a little close to the circle. I will make it the salmon pink. And we'll make that little B. Although I guess that's a little faint. What's a good color? Orange. Okay. So as we move A and B, little a and little a moves around, and as we move C and D, little b moves around, but our construction stays as is. And we still get the harmonic mean and geometric mean, and it even pops over to the other side, even if b is less than a. And we can rotate it as we wrote. Whoop, what happened there? What's going on there? Oh, the G point is... Oh, here we have GE. E is lying outside the circle, so there we go. That comes from the fact that these are fixed to particular parallelograms, but in real life, you're only constructing the one picture from one given length. I'm just showing you that as we rotate, these guys rotate with us, and we get the geometric mean, the harmonic mean, the quadratic mean, and the arithmetic mean, which is a nice pictorial representation. These guys have good algebraic, like they're described by algebraic formulas. So they have nice algebraic properties, which maybe I'll do someday in the future, but I like that you can do with straightedge and compass. You can get a picture that has 4 of these very important power means, as they're called, all together. I think that's pretty nifty. So, thanks for watching, and I'll see you guys next time.